Good afternoon, guys. It's Naveen joining the call. Can you guys hear me? Could you please type in chat window?
Hello, Naveen.
Yeah.
Naveen. So I discussed that GCP account wala thing with Nirnoy. Okay, and he said ki to proceed with other trainings and park GCP for time being till the time like he fixes that account wala issue. So you can continue with other topics. You can park GCP as of now.
Oh, okay. Sounds good, Aniket. Then in that case, I'll continue with the Openstack.
Yes.
So, okay. So I think I just got started with the Openstack. I'll continue the discussion on that. Rahul, in the meantime, when I'm covering some of the theory, could you please log into the Openstack that is installed on your machine? Take care of all the pin and things like that. I think we need a pin or something like that. So if you can take care of that while I cover my theory, it will save some time.
Okay, sir.
Thank you. Okay. So just adjust my screen here. There you go. Okay. So OpenStack, if you recall, it is acting like a cloud platform to create public and private clouds and also hybrid cloud. We can also think of it like a content management system, which is allowing us to create various kinds of resources, the compute, storage, the networking resources on the cloud. And the main objective is being able to provision a virtual network, whether it is a private, public, or a hybrid, is a quick and a brief definition, guys. Let's dig a little bit deep into it. So here are some of the primary components. Some of them will cover. On the top, we have Horizon. Horizon is the GUI or the dashboard. Here it is an orchestration service, and followed by identity service. Identity service, today we'll try to dig a little bit deep into Keystone. It is the identity and the access management. Then we have Neutron networking service. Cinder is for storage, Nova for compute. Manila Manila is a shared file system, and Glance is where we store all the images. And we'll discuss about each of these things in detail in the coming up days, guys. Swift again, storage service. Ceilometer, a telemetry, or more precisely a monitoring service. Octavia is a load balancing service. So OpenStack is a collection of software tools that control large pools of compute, storage, and networking resources in a data center. So more precisely, we are controlling, manipulating, and making use of the compute, storage, and the networking resources based on the requirements of our clients. It is used to create, edit, or delete virtual resources like VMs, images, networks, etc. In other words, short and sweet, it is allowing us to perform the CRUD operations. If you're coming from a slightly database background, you may have heard about something called CRUD, create, read, update, and delete. Here, we are performing the CRUD operations on, again, the compute, storage, and networking stuff, which is nothing but the virtual machines. You create it, you may want to change it. And again, you create images, you create virtual networks. You may want to update, which is change, you may want to delete, and things like that. So short and sweet, it is performing the CRUD operations is another way to think of it. So the virtualization, ideally, the fundamental concept which existed is about the virtualization, where we have a physical machine on which we put a host operating system. On top of host operating system, we can have one or more virtual machines with the help of a hypervisor. VMware VirtualBox are the popular hypervisors. They allow multiple virtual machines to run on a single single host operating system. So every machine has its own hardware. Hardware is the bare metal, OS is the host operating system on top of it. Generally, we have software applications, and all virtual machines use some hardware. So all the virtual machines are at a slightly simplistic level existing as software programs. Each virtual machine is acting or existing like a software program, which is, or in other words, it is the hypervisor which is making it look like a software program. Internally, how that virtual machine takes care of all the host operating system, the complexity is hidden from us. That is what the hypervisor is doing. Hypervisor makes it possible for the VM to use the compute hardware. Hypervisor is like an OS, but not exactly the OS. So in other words, it's a bridge between the virtual machine and the host operating system and the bare metal. So virtualization is where we have multiple virtual machines, which are since they are like multiple machines sitting in a single machine, we're calling that as a machine. It's like a machine sitting on top of multiple machines, guys. Okay. Traditional architectures, we have separate boxes of hardware and software, but ideally virtualization is where we are plugging in multiple VMs into one and using it on one server or one computer using the hypervisor. So using low-cost commodity servers, in other words, commodity servers are much cheaper compared to the enterprise class servers, and commercially off-the-shelf hardware, they're also referred as COTS, which stands for commercially off-the-shelf. It has combined capacity of CPU, RAM, disk, and NIC for all the VMs. In other words, more precisely, they are low cost because generally they are not guaranteed. They may go down. Enterprise class servers are generally, they come up with a 99.999% guarantee, whereas the COTS hardware or the COTS servers, commodity servers are generally not given a guarantee. So that is why generally the data is replicated across multiple servers. So even though the number of servers are more, the cost will reduce. The cost is much lesser compared to the enterprise class servers. So many individual servers or machines can be accommodated in single hardware as virtual machines. That is what is the virtualization. Multiple virtual machines are sitting on a single virtual machine. And that is what is virtualization. So typical three-tier architecture, we have a web server, an app server, a DB server. The web server is generally hosting the UI layer. The app server is generally hosting the business layer, the data access layer, and the web services and things like that. Database server is where we have the database. This is generally a traditional three-tier architecture. And the three-tier architecture can be deployed on a single server. They can also be deployed on multiple servers at a physical level. So in virtualization, again, we can deploy these three layers in a single virtual machine or multiple virtual machines also. So advantages, again, we still have hardware, but it is efficiently utilized now. In other words, it's making look like it's multiple machines. So the costs can be more by using multiple virtual machines in a single machine. A separate server for every application could be either underutilized or overutilized with respect to hardware resources, which means if we were to deploy each layer in a separate server, it is possible only one of the layers is used heavily and the other layers are not used heavily. In such case, the chances of underutilization and overutilization will come in, and we may be spending too much money and we may not be getting the worth out of it, is what is the problem, guys. Okay, the VMs can be allocated with only that much hardware which is required for them. So it is possible for us to manipulate, permutate, and combine the combinations of compute storage in such a way and allocate right amount of resources to specific VMs where there is heavy load based on the load and the requirement that can be observed. That's what that is saying, guys. Okay, so creating a VM is a matter of few seconds. So it is much more simple and easy to create a VM than provision a complete server on a need-to basis. COD servers are cheap and easy, so that brings down the cost for many of the companies, and that's why the birth of the big data and all those things came into the existence, guys, because the data has grown big. And earlier, because the enterprises were using enterprise class servers, they were not able to invest that amount of money. That's why they started using commodity servers, which is nothing but the COTS is what it is. So with increasing number of users, the application must be scaled up. which requires the scaling up. There is again scaling up versus scaling out. You might be already familiar. Scaling up is where you're increasing a single machine, the number of RAM, CPUs, and other components of it, making it more powerful. Scaling out is where you're increasing the number of servers. Horizontal scaling. Scaling out is horizontal scaling. Scaling up is vertical scaling. Deploying large number of cloud servers to derive as much computing as required is called cloud computing. Again, that is one of the major advantages. We can achieve both of them using the cloud computing. Cloud is just someone else's computer, that someone else is a cloud service provider. That could be Microsoft, that could be Google, or that could be Amazon. Again, it is a data center with a lot of virtual networks, or in other words, short and sweet. A data center is a group of networks and clusters, or more precisely, a data center is a group of clusters. Clusters is a group of servers and networking is what it is, guys, okay? Then again, we briefly, we have already discussed about the public and the private cloud. Hundreds of data, Google Cloud, Google has hundreds of data centers around the world in different regions, zones, and things like that. Private is where we do not allow any public access. An enterprise wants an exclusive access, whether it is the compute, storage, or the networking. Those are the three mantras of the private. They want exclusive access without really the other traffic going through them, is what it is. Another friendly look at cloud, the public versus private is public. Cloud is something like an apartment building. You're renting in an apartment or renting a flat in a society. You enjoy the hassle-free services and pay for it. So in other words, all the maintenance is taken care of by the apartment guys. If there is any problem in your apartment, they already have the people. The security is taken care of. And many other things that we generally have in apartment, we don't have to explicitly worry about them. That is being provided by the apartment. You just rent what you need. You can pay as much as you need, and you can go. Is what it is about. So it is being managed by someone else as a cloud. It is costly. And again, the cost also, if you are using it for short and sweet, it could be much cheaper. But if you're using it for a long time, then there are different ways how we can optimize the cost. So our AWS, Azure, and GCP are generally your apartment builders. These are the guys who are providing the cloud services and so on. Coming back to a private cloud, it's like your own house. If you have your own house, you have to take care of security. There might be other people who might be passing through across your road and things like that. So you need to take care of the security. If there's any problem in the laundry or maybe the bathroom, you need to take care of them manually. So it is managed by yourself. It is one-time investment and lifetime usage. So again, there is a lot of money we invest upfront compared to the public. In long term, there will be much more savings if we have a long term. In short term, public has much more savings. Private data centers by banks. So banks, governments, telecoms, they have a lot of confidential data which they do not like the others. They cannot expose it to the outside world. So they generally prefer the private clouds, is what it is, guys. Okay. A little bit more theory. Hardware types. Again, private cloud is hardware agnostic solution. In other words, you can use any kinds of hardware. HP, Nokia, Dell, these are the different kinds of hardware manufacturers. It can be deployed over any COTS hardware. Again, you can use different kinds of commodity servers, is short and sweet. And again, a slightly physical view on the right-hand side, what we have is a rack view or a physical view. It is slightly Openstack, or in other words, if you start on the left-hand side, the hardware is the bare metal. On top of it, we have the host operating system plus the hypervisor. And on top of it is what is the Openstack, which is a cloud management system, which is helping us manage the cloud. And a slightly deployment view is where the under cloud and the over cloud things come up. The switches and the cables are used for connecting the different kinds of hardware aspects of it. And this is what we'll discuss in the coming up, guys. Okay. So a quick look at the under cloud. Under cloud server or a director machine is the installer of the cloud servers, of the over cloud servers. In other words, under cloud is like a management office. If you're building an apartment, your under cloud is where you have an office. What is it? It is used for building this one. It is used for managing the operations of building the apartment buildings and so on. So that is referred as the under cloud. We don't perform, you don't construct anything. The construction is done here. This is your private cloud. This is what is referred as overcloud. Overcloud is generally a combination of controller, compute, and storage. And it is like a construction office of a large size. So here it is more precisely, it is referred as a director. Pardon me. Here, for the sake of simplicity, the undercloud is sitting on top of it, but you may want to visualize it as if it is sitting below. Because it is below, we call that as the undercloud, and the rest of them are on the top. So they're on the top is the cloud, so they are referred as the overcloud. At a slightly logical view, you can think of it like that. Okay, and it is generally the director machine generally has it is used for only installation purposes of the controllers, compute storages and things like that, commissioning and decommissioning, additional controller, computes and storage generally happens. So that is done via the director. We can also do it using the controller. Controller is the brain of the cloud cluster. It runs all the infrastructure management components. In other words, controller is part of the overcloud. This is, let's see, back to the overcloud. If you go back to the controller and back to the apartments and things like that, these are the main management. The controller is the main management. They are taking care. They're kind of taking care. They're the project managers or the project managers from a civil engineering perspective who are taking care of the building, and they're tracking everything. They're taking care of the resource allocations and many other aspects of it. Openstack controllers run in active mode. Generally, the controllers are, we use only one or two of them. They're generally the enterprise class servers. The computes and the storage are generally the COTS or the commercial, the commodity servers. They're cheap servers. So controllers are active standby mode generally. For each enterprise class server, we generally have a standby server also, just in case the primary goes down, the standby picks it up immediately and starts serving the request. And most of the time, the enterprise class servers give a very high availability, so generally they don't go down. But it's generally good discipline and practice that the companies go by the active and the standby mode. They use load balancing to address scalability and high availability. So in other words, they are the main, they are the brain. They also take care. They have high availability. They have high availability and scalability built into the enterprise class servers compared to the commodity servers which we need to take care of manually. The computes is where the actual processing is done. The actual processing is where the VMs are created, modified, and things like that. Then again, within the VMs, we install multiple custom applications and softwares. We perform computes and things like that. So all those things happen in the computes. Computes are generally the commodity servers. Their resources are managed by OpenStack. In other words, more precisely, controller. These are the workers. You can think the computes are the software workers. The storage are the hardware workers. Or in other words, think of compute as the software developers. Think of storage as the hardware developers. And the controllers are the project management team. The project management team generally manages the software, and the hardware developers is one way to think of it. So all the processing is taken care of by the computes, or whatever is the processing. But after the processing, we need to store the results somewhere. That is where the storage comes. The storage is where all the results are, the input and the output data is stored. Anything which is being processed, you take the input data, we process it. That is being performed in the compute servers. So many hard drives are used to provide shared storage. So in the world of big data and things like that, when enterprises have terabytes and petabytes of data, all the data is generally the input data. For example, enterprise or company may want to get the last 1 year, maybe last 10 years of tweets, and they want to perform some kind of sentimental analysis and things like that. In such cases, the data will be very, very huge. In such cases, they don't really go the enterprise class servers, they buy the commodity servers, and that is what is the storage nodes. They store the data, and for storing that amount of data, we may need multiple HDDs, SSDs, multiple volumes, drives, and other aspects of storage is what is needed. If compute nodes have enough storage capacity, then these nodes are also not required. So in other words, again, compute node can also be used as storage nodes when we have small amounts of data, but when you have huge amounts of data, generally storage nodes are separated, is what it refers to. They can be used ideally interchangeably. You can also use a storage node as a compute node also, but that depends on the architecture of the architect who has an idea of the kind of requirements and so on, guys. Okay. And again, The overclock, the controllers, compute and storage are generally top, and the underclock is this one. So they generally referred as the overclock, and the underclock is just used for installing other components and things like that, guys. Okay. So generally, this is the picture. In a production environment, all these are referred as the overclock. O is nothing but OpenStack on OpenStack. Packstack is where we generally use it in labs and for small POCs and things like that for some quick understanding and so on. But when we run any of these services in a single node, 2 nodes, or maybe 3 nodes using Packstack and things like that, ideally the very idea of OpenStack is you should be agnostic. Whether you work, the way you work on a group of small nodes, you should also be able to work on a O based installation. Is what is the very idea. It is not that if you work here, you don't have any idea of working here, and vice versa, guys. Okay. So cloud infrastructure, the spines, routers, firewalls. If you're coming from a slightly background, networking background, you would have probably a better idea. Switches connecting all the cloud servers. Spine switch aggregating all leaf switch outputs into a single line. Routers, the main routers of the custom data centers, guys. Okay, so all the servers are getting connected using the switches. The spine switch is, again, you're connecting multiple racks, I think is what is the spine switch. Router is used for routing the traffic and things like that, taking care of the networks and things like that. So that could also be referred as a separate component, which is referred as a network rack. Is a slight high level idea, guys. Okay, so again, the compute, controller, storage, and the underclock together form the triple O. That is what it is. Again, there is various permutations and combinations how you connect the leaves, spines, and routers is what it is. I'm not purely coming from a networking background, but just a rough idea, guys. Okay. We have redundant connectivity, especially for the controllers. We have redundant connectivity. For the enterprise class servers, there is redundant connectivity, redundant cards, redundant storage, and things like that. For commodity, it may not be really necessary. A pair of leaf switches per rack. So in other words, a pair of switches per rack, just in case one switch goes down, another pair handles it. Pair of spine switches and gateway to the external world to get the external traffic from the external world into the internal world is what that one is about. Okay. Ideally, we may log into an undercloud or a director perform all the operations. We can also directly log into the controller. We can also directly log into the compute and storage. We just need to load up the necessary admin files. They are admin RC files and impersonate our user and run as an admin or maybe a specific user. Horizon again is a GUI for us to access it, access the OpenStack. Most of the time we will be using the command line, guys. Okay. So again, controller, compute, these are the terms which are used. Controller, compute, or more precisely, there might be multiple virtual machines in a compute. The controller can also be used as a compute in a small project and things like that, or when the budget is not very high, is what it is. So there it is. That is a horizon. We generally log in as an admin user, and one of the things is we need to have an idea how to monitor and things like that. That's what we'll try to. For all the admin related operations and tasks, cloud nodes as well as VM. So in other words, admin has access to, admin is a super user or the root. He has access to everything. And all the other users that we generally create, we create a user followed by a project, followed by roles and so on. All of them does not necessarily have the access as an admin. So majority, not all the operations can be performed from the horizon dashboards. In other words, most of the time we will probably use the CLI. Or in other words, CLI is a superset of all the operations that can be performed than the horizon GUI. The horizon GUI has lesser set of options than the CLI guys. That's what we're trying to convey there. So okay, so that's a quick link for getting the Red Hat enterprise documentation, and that is just a quick link there. Again, OpenStack platform, just in case there is OpenStack, docs.openstack.org is one of the places where we can get more on the things, guys. Okay, so before we get on to Keystone, let me see. Okay. Why not we get started? And Rahul, can you quickly share your screen and just show the horizon GUI for a quick second, please? Horizon GUI and the CLI.
Yes, sir.
Okay. Can you log into the horizon? We can clear it. You can clear it.
Yes.
Oh, sorry, you're looking for the password. Okay, and let's see how many users are there. On the left-hand side on the top, let's say a symbol of the Openstack. Can you click on the drop down on the top? Just you just have admin project. Okay, so there is a project, then we have the admin and the identity. And under the project, you have compute, volumes, network, orchestration, and things like that. Let's see, click somewhere else. Project compute and overview. Okay, click on identity. The last one. Projects. Admin and service. You didn't install the demo. Okay. And then click on users, please. Okay, glance sender. So these are actually the service names which are being used. Then click on groups. So we can, if you look at the users, we can get a quick idea of some of the services which are already installed, which is the glance is the core. Then you click on the users one more time. Sorry about that. There is a glance, and then Nova, the compute, heat is orchestration, neutron is networking, placement. I don't remember what is placement. Cinder is for storage. These are some of the core, most important core components, guys. Then click on roles. Roles can be thought of as a group of users. Groups can also be thought of as a group of roles. And it looks like some of the services are automatically creating heat stack owner. That is a heat. Okay, member. And roles, admin. Okay, we also have admin. Application credentials, please. Okay, application. So ideally, if you, on the right-hand side, if you see there is something called create application credential, just click on that on the right-hand side. Expiration date and things like that. So, okay. Application credential. This is where I think we create the key pairs and things like that. Secret expiration date, access roles, and things like that. It's application credential. Okay. Okay, we'll see. I think maybe they're getting created based on a project. So let me share my screen for one quick second while you're there. Okay. So the keystone, let's Keystone. It follows a RBAC process. RBAC stands for role-based authorization and control. So ideally Openstack client, which is different kinds of Openstack services and things like that. When we log into the Openstack, what is happening is it first interacts with a service called Keystone. And we provide the username and password. Keystone is then giving us a token. If the username and the password is valid, Keystone gives us a token. It then internally stores in its own database. And for any of the subsequent requests which are being performed by the OpenStack will share this token with the subsequent services. The services, any other OpenStack service, which is like a glance, maybe no computer networking and things like that, the first thing they will do is they will interact with Keystone. They will give it the token that the OpenStack client has given. And the Keystone will verify if the token is there in its database. If it is there in the database, that means it has been validated successfully. And it says, yes, you can continue. This is a valid user. So that is what is happening in this tab. So that is the first step where the OpenStack client will get the token. Then the subsequent, this is where the subsequent services, the other kinds of services are given. So if you notice the red one, the client is giving the token to this one. The token is again being sent back and given to the Keystone and verified. The Keystone then verifies and says, yes, it's a good one, and things like that. We'll try to dig a little bit deep. So authorization process, a role defines user access rights within the clouds. In other words, a role is a group of users and their permissions. Determines whether user can perform specific API operations, whether you can perform certain kinds of operation, whether you can create a VM, an image, or a server, an instance, and things like that. So roles are created in Keystone by the administrator. So again, an admin logs in, he will first create the roles based on the project's requirements. Each service has a policy engine module, which means if you recall the first step, which is here, this is the first step. When a client, the first time when you log in, the login screen is acting like a client is communicating with the database, giving the proper username and password, getting a token. And then here in the second step, what is happening is this is where the policy engine is coming into the picture. What policy engine is doing is every service is having the policy engine. Each service, a policy engine module. And what does that do? That is actually communicating with the Keystone before it does anything. The first step it is doing is it communicates. The Keystone then goes back to its database and it verifies if the token is there in the database. Only if the token is there, then it will give a yes, and the remaining operations will be performed by the service. So role-based access control policies are defined in the policy.json. Ideally, a policy is something which has a combination of the roles and the services and the permissions and things like that. The policy engine determines whether to accept or deny the API request using the policy definitions. In other words, that is the part of the policy engine. The policy engine gives it's a yes or no from the Keystone, and if it is yes, then it can perform any and every operation. Yes, okay. So each policy is defined using the notation key and a value. So kind of a target and rule. A policy target is an API call. So an API is an application programming interface. So in other words, ideally from a programmatic standpoint, what is happening is we can call these services as if they are like objects or classes and invoke their methods. And when you invoke their method, internally the service is checking if the token is valid or not. So create an endpoint specified as identity create endpoint. Identity means Keystone service. Create endpoint is an API call. The rule determines the situation in which API call is permitted. So again, the rule is where the validation checks if the object's owner is performing the action. Owner means if you have the access, then it is allowing you is what it is. Guys. The owner can also mean admin is like the super. He can do everything and everything, but there are certain users when we create, we need to give certain roles. Only if they have the roles and the permissions, they will be able to execute these calls is what it is. Check if the user has admin role before performing an admin action. If you're an admin, then you can do anything and everything is what it is, short and sweet. So here is identity, create endpoint, role, and admin. So in other words, only admin can create endpoints. So each of the service, or maybe if we create something new in Openstack, then we can expose its endpoint. That is what this create endpoint. You are able to access the URL of it. That is what they create. So here we are restricting only admins to be able to create an endpoint. Not every user will be allowed to create an endpoint, is what it means. Default policies are defined in each project's policy. So again, policy.json is a file where generally this kind of mapping is done, which users and which roles are allowed. New roles in Keystone must map to roles defined in policy.json. It is again the same thing. Policy.json is a file which will have a map of all these keys and values is what it is, guys. Okay. So some of the main terms in Keystone. World project, also known as tenant. In the slightly older versions, the project was referred as tenant. And a user is a user, as simple as that. User generally gets a token. So the first step is we create a project, then we create a user, then generally a role is created. The role is group of users. Then we have region service endpoint. These are all the, this is a catalog service discovery. In other words, each service is exposed using an endpoint. A region is a group of zones, and the zone is a group of, can be thought of as a group of data centers. So catalog service discovery means you're discovering service. In ours, it looks like when we just looked at, we just had glance, we just had sender. Openstack has 30 to 40 such services. We don't have all the 30 and 40. Generally, we install the core services, we try to customize any new service and things like that, guys. Okay. So what is that? When we look at that one and we try to understand, we are discovering what is there. What is the set of services which are there? That is referred as to service discovery. You first try to know what is there, and then you try to make use of them. That's what is service discovery process, guys. Then we have domain. Domain is generally per client. Under client, there might be multiple projects, and under each project, there might be multiple roles and users as what it is. Group again is a combination of roles and users. A role is a combination of permissions or users, but a group can also be thought of as a group of roles and users is what it is. So again, Keystone is a common authentication system. So mainly it is authenticating. When you provide a username and a password, it allows us to create the users and then make sure if the user is valid or not, they're given the right username and password. That is authentication. Central catalogs of services and endpoints, we can find that. That's what we'll see. Supports LDAP, AD, and MySQL in a enterprise or in a business where you have lots of Windows and other kinds of databases and things like that, Windows machines. It also has support for that. Provides a token for subsequent authorization requests. So as I said, the first thing it does is it gives us a token, if the and then that token is used in the subsequent request, guys. Okay. So again, user is a user project. Generally, the flow is we first create a user, then we create a project. The project is assigned user, then we create a role. The roles can be globally scoped. Globally scoped means across all the projects. Project scope means for a specific project. Most of the times the roles are project scope. Only admin is globally scoped. He can touch every project is what it is. And tokens is the one which is generally handed over by the Keystone internally. Catalog is where you look at this catalog and try to understand what are all the services available for implement. So again, the first step is you get the token. Then the subsequent, we are getting the token here from the Keystone. Then again, this is scenario, maybe we are trying to create a Nova compute, a VM, or maybe an image, or maybe we are trying to provision a network. So this is the steps. Each of the service, once they get the token from the user, they get the token. And what are they doing? They keep constantly going. So Nova goes to the Keystone and it verifies it. Then again, similarly, the glance, whether you're creating an image or maybe changing the specs or the configuration, it is again going to the Keystone, verifying it. Similarly, the Neutron, a slightly what we call an interaction or maybe a sequential diagram is what it is referred to, guys. Okay, as long as you remember, the first thing that any of these services do is they're verifying with Keystone. That is what is the important part, guys. Okay, so let's say back to you, Rahul.
Yes.
Okay, so if you go back and just carry the RC, admin RC. If you see there is something called OS authorization URL, that is what is the keystones endpoint is, that's where we should be, or in other words, that's what OpenStack is periodically verifying it. So if you, you have already sourced it, haven't you?
No, sir.
Go ahead and source that file, whatever that name is. So one moment, buddy, one moment. So before you source, let's say you say OpenStack endpoint list. Don't source it. Just type an OpenStack endpoint list. Let's see if that's already sourced. OpenStack, OPEN.
Okay.
Open, buddy, OPEN.
Yes, sir. The server is running.
Okay. Oh, okay, it's already there. Okay, so you already loaded up. Let's see. Do an OpenStack endpoint and just grep for identity. Okay, so let's see what we have. Region 1, and we have 3 of them.
Yes.
How come we have 3? Sure, sorry, my bad. One is for admin, internal, public. Okay. So the admin one is at 35357. The first one is what is the admin endpoint is, and internal is for internal private network. Admin is for only administrative managerial tasks, which is generally used by the controller. Public is for any internet access and things like that. Is what it is. So here, pick up any one ID, just copy one ID, maybe the first one, yeah, and just say OpenStack endpoint show and paste that ID. Show. Enter. Okay, so that gives us very specific information. The region is region 1 service, is the service ID and things like that. We'll try to understand it. It's also enabled. These are some of the common fields or the attributes that we'll be looking for other services and so on. Yes, that's just a quick touch of it. Then do a OpenStack catalog list. So if you scroll up a little bit, we have Nova, Legacy, and do we have Cinder here? Scroll up, please. Cinder.
What is running?
I think a very, very minimal stuff is there generally. So there's a heat, there's a CFN.
Like
Okay.
red, different.
No, that's okay. Just scroll up a little bit, show the other things quickly.
Server is running.
You're not able to scroll up. Huh?
Yeah, I'm scrolling little bit and running very fast.
Okay, Nova heat and things like. Okay, so ideally one of the things I just quickly wanted to say was Cinder volume 3. So you may also find a slightly scroll up and see if there's a Cinder V1. Cinder V3, Cinder V2. If you're noticing, there's something called Cinder V2 and Cinder V3. So in other words, they have provided the endpoints of both the version 2 and the version 3 of the Cinder service. That is something to be kept in mind. That is generally when they make some major changes in the releases and things like that in a particular service, what they do is it could be possible if they directly release the latest changes, it may end up being very sensitive and it might break in other places and things like that. So just to be on safe side, they will always provide a previous version, and the latest version is also provided. So by default, the previous version will be used. And if somebody needs more updated calls and things like that, the latest versions in the V3 endpoints will be referred, is what it is about, guys. Okay, that's what I'm trying to convey there. That is just to give you an idea. Let's say, try to create a project. Openstack project create, just say maybe proj1. Project create, say proj1. And do a project show. Project show proj1. Same output. Openstack project show proj1 buddy, the name of the project. Okay, similar output. So the description is empty. Domain ID is the default here. Generally for each client, we would use a different default, like in other words, for each organization, generally a default domain ID is used. Enable this true means the service is in use. ID is domain, is domain, whether it's a domain service or not, I think is what it refers to. Name is name, options is a group of keys and values. We'll see. Parent ID is the default and tags is empty. List object is what is. So let's say, just say Openstack project, set description. Project, set hyphen description. And let's say, just say space proj1 description, this item in double quotes. Project description, yeah, enter. Then show it again. Oh, sorry, proj1, you need to give proj1. After the project one description, at the end, buddy, at the end, go to the right hand side and space proj1. Setting description for the project one. Cool. Then show it. Cool. Proj1 description, as simple as that. A few more commands. Let's say create a user just like a project. So OpenStack user create. Hyphen project proj1. Proj1 and hyphen password hyphen prompt. And let's say prompt space. Just call, just say Rahul or something like that. Rahul1 or something like that. Yeah, enter. Should be given a password prompt. Yeah, give the password. Okay, so here we created user, then we'll create a role. Just instead of OpenStack user, You can say OpenStack role. What do you have? Just do an OpenStack role list, please. Eight reader and so on. Okay. OpenStack role assignment list. Oh, I'm sorry. Do an OpenStack role add. Just like user create, we do a role space add. Hyphen project one. And add space. Then hyphen user Rahul 1. Space admin. Enter. Okay, now go back, bring up the horizon. Try to log in from there using the username and password you created. You can log out. Okay, I think we created you as an admin, so you will have access to almost everything, just like an admin user.
Yeah.
So there's a project, and if you click on identity, go to the projects, you're able to see everything there. So there's the project one we just created. And let's see, go back to, let's say, identity, and you're in the projects, right? Click on project one. And go to the users. This is Rahul. Click on Rahul 1. Primary project. Click on role assignments, please. Where we go back to identity and projects. Click on identity projects, not the users. Now click on project one. Project one. There. And what is it I'm looking for? Can you click on users once? And groups. If you come on the right hand side, there is something called manage members. Click on that one on the right hand side. Edit project. Go to the project members. Now you're an admin. Change that admin to, click on the drop down and select underscore member underscore. Keep that. Okay, just click on save. You cannot revoke. Oh, okay, cannot revoke. So I think it's forcing you to keep the administrator, because at the time we created the admin. Okay, so maybe at the time we created, if we had created only that one, we can quickly test it out. Go back to that one, the screen. Just create another user, maybe Rahul 2 or something like that, and just give him the.
Maybe if we log in using that admin credential, we can change it.
Pardon me? Using the admin.
Yeah, admin credential.
You're already an admin, right?
No, we are Rahul one actually. Currently, I have logged in using Rahul one credential.
Your role was admin, isn't it?
Yeah, role is admin.
Yeah. So you're like an administrator. Whatever an admin should be able to do, you should be able to do, Rahul. So just create another user, Rahul 2 or something like that. And just give him underscore member underscore. We'll test it out. User create, yeah, Rahul 2.
And
Yeah.
role.
Enter.
Role.
Then you do an Openstack role add, and this time instead of admin, oh, sorry. There you go. Instead of admin, just give him Rahul 2 and admin underscore member underscore. Okay. Yeah. Go back and verify in horizon. Rahul 2 is just only a member. As simple as that. So if you were to log in as Rahul 2, then you will be having only the member, whatever the services which are accessible to a member and not completely all the services is what it is.
Yes.
Catching it?
Yes, yes.
Okay, so just back to the CLI, just type in OpenStack command list. Enter. So if you scroll up a little bit, these are all the possible commands from volume till everything, which is there. But ideally, maybe you can just grep for identity so that we don't have to, you don't have to scroll up too much. So grep for identity. Identity.v3. Provide, can you grep for keystone? So identity openstack.identity.v3 is your keystone. But let's say, so since I think it's a very skeleton setup, we're seeing very small list. I'm thinking is what it is.
This is actually a different setup. You are teaching is triple one, triple O one, and this is actually Cola and Cibo.
No, I was also actually referring to the hack stack only, but sorry. Rahul, could you take a 5-minute break? Sorry about that.
Yes.
I'm back, Rahul.
Yes.
Okay. We'll try to create a user in Horizon, and we'll try to change some of the roles, users and role permissions, and we'll see how it goes. Sometimes you may have to come across those scenarios where you're changing this, where somebody's created in Horizon and you need to change it in CLI and vice versa. So that will give us a quick idea.
Actually, now we already know all these things like managing users and all. We
Okay.
already did that. We want to know the deployment, like triple O deployment. We are facing difficulty there.
Yeah. So you don't need me to go into the user roles and things like that. Is that okay?
No, sir. We already know this basic.
Okay, deployment. Okay, the triple O thing. I myself am looking into some things on the Google Cloud. I've been playing with a little bit. The only thing we need to manually install for the triple O, we need to manually have the RPMs and things like that manually downloaded and things like that. Only then it looks like the Red Hat Openstack is allowing us to install. And I'm still looking into it. I need a little bit of time. Shall we go ahead and install on Google Cloud the tag stack thing?
Yeah, we can start from there. Like first we'll do patch stack, then we can do the triple O.
Okay. Okay. Let me come back here. Let's see where we are. 1 moment. Can you log into the Google Cloud, Rahul?
Yeah. Actually, our Ansible module is also remaining, right? This Google for this Google account, as Aniket said, we need to wait for the account. So can we learn any other topic like Ansible? We have ELK also. So many topics are here.
Yeah. What about the Nova and all those other modules?
Nova, it is there in OpenStack, right?
Yeah.
Yeah, we know this basic, like what is Nova, all these services and all.
Oh, okay. You want me to jump into that one? Okay.
Yeah, we know. We just want to learn that deployment, the triple O deployment,
Oh,
HI deployment, and all.
oh, okay.
Yeah.
Sounds good.
Or yeah, there are. If you will cover it later, then we can do a different topic now, like yeah, Ansible and everything. It is still remaining, right?
Yeah. Okay. Give me 1 moment. So in OpenStack, you're only looking for the deployment, right, Rahul?
Yeah. We want only deployment, mostly the triple O deployment with HI.
Okay. Sounds good. Let me see. Give me 1 moment. My mouse is not working. Okay. Let's see. EKS. For EKS, I think the last one. In EKS, I think I wanted to show you how to hook up the ELK, right, Rahul? That's where I think we were, if you recall.
Yeah. We want to do that ELK thing on Kubernetes. Right?
Yeah. One moment. Just log into your AWS, Rahul.
Should I share my screen? Or log in?
Yeah, please share your screen. I think we may need to create an EKS cluster.
Yeah, we need to recreate it.
Yeah. Is that already up and running? Is server 1?
We need to start it.
Okay, go ahead and start it. Is that the one EKS that we created last time?
We have used this server. First, we have logged into this server, and then we have run that command to run to create that EKS cluster.
Hmm. I think we need also to create the workers, right? EKS server is just management node. If you manually start like that, then I think we need to figure out which are the workers which are running on that. We may need to manually hard code it. In our bring up your Git bash, please. Okay. And I think you need to.
Should I connect?
Yeah. City user. Okay. So last time I think we did apply. So I think some of those files should be there. Can you do an ls? We did a k-test log. Let's see, deployment. No deploy fluentd. Can you get the fluentd.yaml? Scroll up, please. So it's a service account, cluster role, and cluster role binding. Could you scroll down a little bit, please? Going down. Fluent. Flat.js, brush logs, chunk size. Scroll down, please. Further down. Okay. And let's say raw groups. Can you do LS one more time? Just thinking. Could you get the K? No. What is that one? Deployment.yaml. Three replicas, match levels, things like that. Okay. Can you paste this? What is this? The k.pms in the chat window, please, so that I'll log in from here also.
You want to connect this server?
Yeah.
Okay.
Okay. 1 moment, please. Open this one. Oops. The k8s.keep.com, can you just put back on the G drive, Rahul?
That link which I have shared in the chat window.
No, the perm file.
Okay, thanks.
Let's go to this one of the file k8s.
Actually, I don't have permission uploading.
Okay. In the Google Drive, you mean?
Yeah, I don't have permission.
Oh, okay. How did you get it last time? Is there ktest.com? Okay. k8s_key.com. Okay. Okay. Let me do this, Rahul. Can you WhatsApp me that one? And what we'll do is we'll continue tomorrow, Rahul. I don't want to waste your time because I'm trying to figure out where I was last time. So I just don't want to waste your time and things like that. Can you just give me WhatsApp of that one, please?
Okay.
So Aniket and Shrishal, for today I'll wrap up here, guys. Tomorrow I'll dig a little bit deep into the ELK part of it, and we'll also start with the Packstack install. I need a little bit more time on the Tupelo deployment and things like that, and we'll continue. There are a few more topics. Ansible, do you remember what was the topic that we were?
That playbook one. We have just touched the playbook.
Okay, sounds good. Yeah, and okay. Do by any chance do you remember if you have Ansible installed on any of the servers, Rahul?
Maybe we have one.
Oh, that's okay. That's okay. Don't worry. I don't want to take up your time. Okay. Playbooks. Okay, I'll try to come up with a few more, and we'll dig a little bit deep into the Ansible playbooks.
Yeah. Okay.
Okay, for today I'll stop it here, and we'll continue the journey tomorrow, Rahul. Okay.
Okay. Okay. Thank you.
Thank you, guys. Take care. Bye now.